Approaches to reinforcement learning. First one, policy based oral. Oral means reinforcement learning. Policy based oral contains such directly for the optimal policy. Second one, policy achieving maximum future reward. Second one, value based oral. Estimate the optimal value function Q conversion to S, A. Maximum value achievable under any policy. Model based oral build transition model of the environment. Plan example by look ahead using model. Bellman equation. Value function can be unrolled recursively. Q power pi of S, A equal to E of RT plus 1 plus comma RT plus 2 plus comma square RT plus 3 plus S A, ES dash of R plus comma Q by S dash A dash S comma A. Optimal value function Q conversion of SA can be unrolled recursively. Q conversion of S, A ES dash R plus comma maximum A dash Q conversion of S dash A dash S A. Value iteration algorithms. Solve the Bellman equation. Q plus I1 of S, A equal to ES power 1 dash ES dash R plus comma maximum A dash UI of S dash A dash S, A. Deep reinforcement learning. Human. So action going on. Action, reward, observation. Action, reward, observation. It is happening in human. So what is deep reinforcement learning? Environment, raw observation, reward, then actions, then environment, and run raw observation, award. Here in reinforcement learning happening. Deep reinforcement learning represent value function by deep Q network with weights W, Q of S, A, W approximately equal to Q by of S, A. Define objective function by mean square error in Q values. L of W equal to E R plus comma maximum dash Q of S dash A dash comma W Q of S minus Q of S comma A comma W. This is the target leading to the following Q learning gradient dou L of W, that is L means leading divided by dou W equal to E of R plus comma max A dash Q of S dash comma A dash comma W minus Q of S comma A comma W dou Q of S comma A comma W dou W. End-to-end TQM in Atari. End-to-end learning of values Q of S comma A from pixels input state. S is stack of raw pixels from last 4 frames. Output Q of SA for 18 joystick but per button positions. Reward is the change in the score for the step. Here convolution fully connected. This is happening 2015 paper. Taken in study human level control. This is 2015 paper. AlphaGo 2000 Silver David ETL 2016. Sorry. This is Silver learning combine SLRL to learn the search direction in MCTS policy, rollout policy, SL policy network, RL policy network, value network. Happening. SL policy network, period search probability or potential rollout combined with the MCTS for quick simulation on leaf node. Value network build the global feeling on the leaf node situation. Learning to prove SL policy network. Policy network 13 layer CNN. Input port positions S. Output P sigma alpha divided by S, where alpha is the next move. Extended data table. Input feature or neural networks. Policy network POP AS. Feature of floods description. Stone color wants the turns in liberties. Capture sizes, self-40 sizes. Liberties after move, ladder capture, ladder escape, sensibleness, zeros, prayer color. So here number of plates 3, 1, 8, 8, 8, 1, 1, like this. Description. First one is player stone divided by opposite stone divided by empty. Second one, a constant plan filled with 1. Third one, how many turns since move was played. Next one, number of libraries empty adjustment points. Then how many opponent stone would be captured. How many of own stones would be captured. Number of liberties after this move is played. Whether a move at this point is a successful ladder capture. Whether a move at this point in a successful ladder escape. Whether a move is legal until it does not fill its own eyes. A constant blindfold with a 0. Whether current player is black. Learning to prove RL policy network, SL policy network, RL policy network. So P sigma PP policy gradient self plane like this. So 1 million samples are used to train RL policy network versus SL policy network. RL policy alone it wins 80% of games against SL policy. Combined with the MCTS, SL policy network is better. We should derive the value network as the ground truth, making enough data for training. Learning to prove value network. RL policy network with value network with data self play regression self play position regression similar architecture VP of S equal to E of ZT ST S comma AT T approximately T proportional to P. SL network sampling to generate a unique game. RL network simulate to get the game is final result. Train 50 million mini patches, 32 positions, 30 million unique games. AlphaGo evaluation. Silver David. Your references. But until recently, deep networks could not be efficiently trained. Deep breakthrough in 2016. 3 people. Tornado, Hidden, Winklow, Montorial, Leaken Network. Hidden, these people. Okay. So, fast learning algorithm for deep nets neural computation in 2016. Pendulum. This person greedy layer-wise training of deep networks. Then this person Lincoln, New York efficient learning of space representations with the energy based. Conventional neural networks CNN input 32 cross 3 32 cross 32 failure maps C1 C3 mapping here also S2 map S4 maps C5 layer F6 layer output here convolutions here subsampling here convolution here subsampling here full connection Gaussian connections. Compared to standard forward neural networks with the similarly sized layers. CNN have much fewer connections and parameters, and so they are easier to train, while their theoretically best performance is likely to be only slightly worse. So, conventional kernel filter. Apply conversions, so we got result like this. Input 32 cross 32 feature maps, C1 feature maps, S2 feature maps, C3 F map like this, S4